Hello everyone, and welcome to Week 2 Science. This is Dr. Young. Today we will be exploring energy transfer and transformation. Specifically, we're going to be looking at the way objects can transfer energy from one object to another with force. For our experiment today, we will be using 2 balls, 2 foam blocks, and 2 Hot Wheels cars. For your assignments today, you're going to be looking for objects around your home that you can do this with also. We're going to begin with the 2 balls. We know already that round objects tend to move easier than stationary objects or flat objects, but today we're going to see just how different the energy transfer is. So when you do this experiment for your assignment, you're going to place one object in front of you, and then you're going to hold the other object. You're going to create the energy motion by rolling your object into the other. So we can see that energy is going to transfer from the ball on the left to the ball on the right. Then we can try it again with cars. Since cars have wheels, we can probably expect that the energy is going to transfer pretty well from one car to another. Can you make a prediction? So we're going to take one car and we're going to see what happens when we crash one car into another. As you can see, the energy from the black car transferred to the energy in the red car, which went from stationary energy to motion energy. Now we can see if they'll transfer back from the red car to the black car. Notice this time I've turned the cars around so that they're facing nose to nose, and we're going to see if it makes the energy transfer any differently. As you can see, much more energy was able to transfer from the red car to the black car when they were nose to nose instead of being front to back. Now let's try with them being back to back and see what happens. Oops. Let's try again. So that once again went pretty well. Can you hypothesize as to why the energy transfer worked so much better when the car had the same sides facing one another versus when one was nose to back? Now let's try it with blocks. I have 2 foam blocks here. They're made out of foam and they're flat on the bottom. What do you think is going to happen when one block crashes into the other block? Let's find out. When I take one block and I move it toward the other block, what happened? Do you remember what the force is called that stops something from moving? You're going to feel this when you do your experiment. When I hold my block and I try to push it along my table, I can feel the force pushing back on my finger. As you can see on my fingers, I'm actually pushing pretty hard and the block's really not moving very well. Now, if I were to push that same amount on the car, what do you think is going to happen? So now I'm going to push just as hard on the car as I was pushing on the block. What happened? The car fell, right? Because the energy transfer when there's wheels is much greater than energy transfer that happens when there's friction. Now we're going to pause and move over to a carpeted area and see what happens when we add friction to our surface. Now we're sitting on my living room floor and we're going to look at how carpet can affect energy transfer. So this carpet's actually pretty thick. You can kind of see how my fingers dig into it. And friction affects energy transfer, and we're going to see exactly how that happens today. So I have my 2 blocks again. Now remember, my blocks didn't move at all on the table. Do you think they're going to move on the carpet? If you guess that they wouldn't move on the carpet either, you are correct. If anything, I'm actually able to push a little less because the blocks tend to just glide across the carpet. Sassy's coming to say hello. This is Sassy. Say hi, Sass. Now I'm going to try again with the balls. So if I have 2 balls and I roll one ball into another, what's going to happen with the energy transfer? Let's find out. As you could see, the balls were still able to transfer some energy, but not nearly as much as on a smooth, flat surface. Finally, let's try with the Hot Wheels cars. Remember that back-to-back or nose-to-nose at the table worked better. So I'm going to try back-to-back and see what happens when one rolls into another. As you could see, very, very little energy transfer was able to make it from the red car to the black car. The reason for that is because of friction. So remember when we did the experiment where we rubbed our hands together really fast and we put them gently near our face but not on our face to feel the heat? That exact force is called friction, and that is exactly what is happening here and not allowing the energy to transfer between the objects. So friction affects energy transfer. Today you're going to be exploring this more in your assignments 1 and 2. Thank you for watching.